Bismillahir Rahmanir Rahim. Peshawar Public School and College. Today we will start next unit number 10, Acid, Bases and Salts, lecture number 1. The topic of our discussion is Introduction to Acid Bases, their general properties and classification on different bases. Now the learning objectives of this unit are terminology, physical properties of acids and bases, chemical properties of acids and bases, uses of acids and bases, classification of acids and bases on different bases, and indicator. So first we discuss about acid. The word origin of the acid comes from the Latin word acidus or acer, which means sour. It means acids are sour in taste. So the word acid is given due to its sour taste. Definition. Now we can define the acids. Acid is a substance that produces hydrogen ions when dissolved in water. So all acids contain hydrogen, but not all substances with hydrogen, they contain acids. Actually, it means that maybe there are some substances which may contain hydrogen, but they are not included in the category of acids. Like ammonia, it contains hydrogen. Water also contains hydrogen, but these are not the examples of acids. So actually the property of the acid is the hydrogen ion produced. This is responsible for the properties of an acid. Now here are some examples of acids given, like hydrochloric acid, acetic acid, carbonic acid, phosphoric acid, nitric acid, sulfuric acid, uric acid, citric acid, and ascorbic acids. Their formulas are also provided to you. Now look at the right side. When we start from the left side of this diagram, that different sources are given, like vinegar, it contains acetic acid. Lemon and the other citrus fruits, they contain citric acids. Tomatoes contain oxalic acids. The grapes contain tartaric acids. And the lactic acid, it's present in the milk. The formica and their legs contain formic acids. And the apple contain malic acids. Dear students, most of the time your Viva questions and your MCQs of the different type of tests, it may contain, they may ask about the sources of these acids. Now next we will discuss about the physical properties of acids. Like acids have sour taste and they turns blue litmus to red. Like given in the diagram, if we take a blue litmus paper and we put it in the acid solution, it turns to red. They have pH less than 7. Now what is pH? pH is actually, as we have discussed, that the acids give hydrogen ion when added to water. So if we take the negative log of hydrogen ion, it gives pH. This topic we will discuss in a little bit in more detail in the next topic. So we can say like the acids have pH less than 7, as given in the below chart, that acids are given from pH range 0 to 6.9, while the 7 is the pH range for neutral substances. It's a neutral range. And the bases are given from 7.1 to 14. This is the pH range for the bases. Now next property. The acids, if they are concentrated, they can be corrosive, like they can damage our skin. Acids are also good conductors of electricity, as they contain ions when dissolved in water, which cause the passage of current. They do not feel slippery, like bases. Dear students, in order to make your concept more clear, watch the following video.
Start of another day at my restaurant, and I'm gathering the freshest ingredients before I begin cooking. Oranges are great to add tang to any dish.
Oranges are tangy because of the acid they contain.
In fact, the word acid comes from the Latin word acidus, which means sour. By the end of this lesson, you will be able to define an acid, define organic and inorganic acids, explain the physical and chemical properties of acids, explain how indicators help to identify acids, list the uses of acids. Any substance that releases hydrogen ions when dissolved in water is an acid. A hydrogen ion cannot exist on its own, so it combines with a water molecule to form a hydronium ion. For example, hydrochloric acid when dissolved in water liberates a hydrogen ion and a chloride ion. The hydrogen ion combines with water to form a hydronium ion. This curd is too sour. It needs a little sugar. Curd contains lactic acid, which gives it a sour taste. Acids obtained from food like curd, lemons, grapes, raw mango, citrus fruits, and gooseberry are called organic acids. Hydrochloric acid, sulfuric acid, and nitric acid are called inorganic or mineral acids. We already know that acids taste sour. Acids also have other physical properties. Acids turn blue litmus red. They also turn methyl orange red. Acids have a corrosive action on the skin. Sulfuric acid stains the skin black. Nitric acid stains the skin yellow. And hydrochloric acid leaves an amber stain on the skin. Acids are good conductors of electricity. Let's try to prove this through an experiment. Pour 5 ml of hydrochloric acid into a beaker containing 10 ml of water. Suspend 2 carbon rods in the acid. Connect the rods with an electrical wire in series along with a battery, a switch, and a bulb. Switch the setup on and see the bulb glow. This shows that acids are good conductors of electricity. Mixing an acid with water reduces the concentration of hydronium ions of the acid per unit volume. This is called dilution of acid. Acids generate heat when they are diluted. This is because the action of acids with water is exothermic. Take 5 ml of water in a test tube and carefully add sulfuric acid to it. Now shake the test tube and touch its base. The base will feel hot, indicating that a reaction between acid and water is exothermic.
Dear students, as you have observed in the video that the hydrogen ion is very reactive and it do not exist free in nature. So it exists in the combined form with water in the form of hydronium ion H3O plus 1. Now next we will discuss about the bases. So first the word origin. The word base, it comes from the Arabic word alkali or alkali, which means ashes of the kali plant. Kali is a wild plant. Now we can define the bases as a base is any metal oxide or hydroxide that react with an acid and it produces water and salt. Now what is metal oxide? Dear students, metal oxide is the binary compound of oxygen with metal. For example, sodium oxide, magnesium oxide, calcium oxide. And what is hydroxide? Hydroxide means when the metal oxide it is added to water, it results in the formation of basic solution which contain hydroxides. So any metal oxide or hydroxide, like suppose if we take sodium oxide or sodium hydroxide and we react it with acid, it results in the formation of salt and water. Now there is given another thing. A water soluble base is called an alkali. Now the question arises, what is alkali and what is base, and what's the difference between two? So those bases which are soluble in water, they are called alkali, while those bases which are insoluble in water, we call to them base or bases. In aqueous solution, they produces hydroxide ion. So all alkalis are bases, but all bases are not alkalis. Actually, it means that all bases which are soluble in water, they are alkalis, but there are some bases which are insoluble in water, so we cannot call to them alkali. So all bases are not alkalis. Like here is an example given, copper hydroxide, CuOH whole twice. It's a base, but it's not an alkali. This is due to the reason because copper hydroxide, it is insoluble in water and it do not produce any hydroxide ion in water. Now there is given a relation between alkali and base and the differences between alkali and base. So alkali compounds are a type of base that dissolve in water. Like those compounds, those bases which are dissolved in water, they are soluble in water, they are called alkalis. A base is a substance that neutralizes an acid, and a base is water insoluble substance, but it can react with acid directly and it result in the formation of salt and water, and the reaction is called neutralization reaction. Like the hydroxide of a base, it will react with hydrogen of an acid and it result, they will neutralize each other and result in the formation of water and salt. The alkali can also react, but alkali is such a base which is soluble in water. So we take its aqueous solution and we react it with the acid and it also result in the formation of salt and water. Now the examples are given, like hydroxide is a common form, sodium hydroxide and potassium hydroxide. These are soluble in water. So these are the examples of alkali. Magnesium hydroxide and copper hydroxide, they are insoluble in water. So these are the examples of bases. Here another examples are also given, like baking soda. It is an example of alkali. In the same way, zinc oxide and copper oxides, they are also given. These are the oxides and they are also insoluble in water. So these are also the examples of bases. As we have discussed in the definition of the base, that any oxide or hydroxide, so the above one, magnesium hydroxide and copper hydroxide, these are the hydroxides form, and zinc oxide and copper oxide, these are the oxides form, but both are insoluble in water, so they are included in the category of bases and these are called bases. So all alkalis are bases, but all bases are not alkalis. I have discussed earlier that all water soluble bases, they are alkalis. So we can say to all alkalis that they are bases also, but all bases are not alkalis, as some of the bases, they are insoluble in water, so we cannot call them alkali. So we cannot say all bases are, we can say, like this will be given, all bases are not alkali. We can say this in such a way. Alkalis are ionic salts. It means, like as I have discussed, all water soluble bases, they give the ions in the solution, so they are ionic salts, while the bases do not give, they are not ionic salts, because the base, they are insoluble in water, so when they are added to water, they do not react with water and they do not give any ions. Look at the above examples, like magnesium hydroxide given in the pink area, uh, magnesium hydroxide, iron hydroxide, zinc oxide, copper oxide, these all are bases because these all are insoluble in water. While in the blue area, sodium hydroxide and potassium hydroxide is given, which is the example of alkali. Now here are given some of the examples of bases and their common names are also given. Sodium hydroxide, caustic soda, calcium hydroxide, lime water, ammonium hydroxide, ammonia water, magnesium hydroxide, milk of magnesia, potassium hydroxide, caustic potash, and sodium bicarbonate, which is also called baking soda. Now here are given in the picture baking soda, caustic soda, ammonia solution, and some of the bleaches which are also contain soaps and toothpaste. They are also contain bases. Now physical properties, the bases, they have better taste They are soapy to touch or feel slippery, like when you dip your finger in a soap solution, it feels slippery. They turn red litmus to blue, like given in the picture, that if we take a red litmus paper and we put it in the base solution, it turns blue. They conduct electricity in the solution because those bases which are soluble in water, they produces ions and they can conduct electric current. Their pH value is greater than 7. Like look at the below chart, as I have discussed earlier, that they are given in the pH value from 7.1 to 14 area. They are poisonous and corrosive to skin. Now, dear students, to make your concept clear, now watch the video in which different physical properties of the bases are discussed.
You will learn about properties and uses of bases. At the end of this lesson, you will be able to define a base, explain the physical and chemical properties of bases, explain how indicators help to identify a base, and list the uses of bases.
Tell me more about a base.
Any substance that can produce hydroxide ions when dissolved in water is known as a base. For example, sodium hydroxide, when dissolved in water, dissociates into sodium ion and hydroxide ion.
How can one identify a base? Do they have any unique properties?
Yes, they do. Bases can be identified with their physical properties. For example, they are bitter to taste. But you must never taste a base, as strong bases are corrosive in nature and denature the protein.
What are these colored strips of paper? What are they used for?
These colored strips of paper are called litmus paper. Bases turn the red litmus to blue. Apart from litmus paper, we can use methyl orange. On addition of methyl orange to a base, like sodium hydroxide, the orange color of methyl orange changes to yellow, and when phenolphthalein is added to sodium hydroxide, it changes to pink.
It's slippery. It feels like soap.
Bases feel soapy on touch. This is because they dissolve the fatty acids and oils from the skin, and it reduces the friction between your fingers as we rub them together. Due to this property, bases are used in the preparation of soaps.
What is this?
Bases are good conductors of electricity in aqueous solution. In aqueous solution, they release ions which conduct electricity. To prove this, let's perform a small experiment. First, we take 10 milliliters of sodium hydroxide solution and 10 milliliters of water in a beaker. Then, we take a cork and fix 2 carbon rods in it. Next, we connect the rods with an electric wire in series, along with a battery, switch, and a bulb. Now, we insert the setup into the beaker with sodium hydroxide. Finally, pass electricity through it. We can observe that the bulb glows. From this, we can conclude that bases conduct electricity.
Ouch! It's hot.
When bases are diluted with water, they give out heat. Let's look at this experiment. We take 5 grams of sodium hydroxide pellets in a test tube. To this, we add 10 milliliters of water slowly by stirring. On diluting with water, some heat is released, due to which the test tube becomes warm.
Now we will discuss about the chemical properties of acids and bases after physical properties. As the chemical properties, these are not given in your books, but I am discussing with you for making your concept clear, because in most of the test and most of the time questions comes from these chemical properties also. So number one is the reaction of metal with acids or bases. Like when the metal react with acid, it forms salt and hydrogen gas. In the same way, when the metal react with the base, it gives salt and hydrogen gas, as shown by the reactions. So the hydrogen gas which is released, it can be tested by bringing a burning candle near a gas or matchstick near a gas bubble. It bursts with a popping sound. This you will experience inshallah in the next video. Actually, they say that the hydrogen gas which is formed if we bring a matchstick, burning matchstick near hydrogen gas, this is the identification or detection of hydrogen gas formation that a popping sound will produce when we bring a burning matchstick near hydrogen gas. The second chemical property is the reaction of metal carbonates and metal hydrogen carbonates with acids and bases. So now when the acid react with metal carbonate or metal hydrogen carbonates, it results in the formation of salt, water and carbon dioxide gas will be released, as shown in the below reactions. But as the base, when they react with the metal carbonate or metal hydrogen carbonate, they do not give any product, or there will be no reaction with the bases. As given in the below reactions, that when the acids they react with the carbonate, so carbonate is we have taken here sodium carbonate, and in bicarbonate we have taken here sodium bicarbonate. So the resultant product is salts along with water and carbon dioxide gas. Now the presence of carbon dioxide gas, this can be detected, and this is a test for the detection of carbon dioxide gas formation, like when we pass it through lime water. Lime water is calcium hydroxide. When we treat it with the carbon dioxide, the appearance will be lime water will turns milky. A milky appearance will you will observe. So actually that milky appearance it will be observed due to the formation of calcium carbonate. But when excess carbon dioxide gas is passed, the milkiness disappear. Like here, then calcium bicarbonate will form. Next is property number 3, the reaction of an acids and bases with each other. Like as we have already discussed, when acid and base react, they form salt and water, and this reaction is called neutralization reaction. This is one of your topic of this unit. In the same way as below, they have given this we will discuss in the salt topic. When a strong acid react with a weak base, acidic salt will form. When the weak acid react with a strong base, basic salt will form along with water. When the strong acid react with a strong base, and in the same way when the weak acid react with a weak base, a neutral or a normal salt will form along with water. Now dear students, in order to observe the chemical properties of the acids and bases, watch this video.
And never store tomato soup in a copper pot for very long. It gives the soup a funny taste.
Tomato soup, being acidic, reacts with copper, and that is what causes the change in its taste. Acids react with metals to form metal salts. In this reaction, hydrogen gas is liberated. Take a few granules of zinc in a test tube. Add 2 milliliter of sulfuric acid to it. You will find that a gas will be liberated. Bring a burning splinter close to the gas liberated. The splinter burns and a pop sound shows the presence of hydrogen. Acids react with metal carbonates to form corresponding salts, carbon dioxide and water. Try this experiment. Take 1 gram of magnesium carbonate. Now pour 2 ml of hydrochloric acid into the test tube. You will observe that a gas evolves. Pass this gas through freshly prepared calcium hydroxide solution, also known as lime water. Lime water turns milky, proving that the gas is carbon dioxide. The precipitate formed in this process is calcium carbonate. Acids react with metal hydrogen carbonates and form corresponding salts, carbon dioxide and water. Take 2 grams of sodium hydrogen carbonate in a test tube. Pour 2 milliliter of hydrochloric acid into the test tube. You will see that a gas evolves. Pass this gas through freshly prepared lime water. The lime water turns milky, indicating that the gas evolved is carbon dioxide. A white precipitate of calcium carbonate is also formed. Acids react with metal oxide to form salt and water. Let's conduct an experiment to prove this chemical property. Take 10 milliliter dilute hydrochloric acid in a beaker. Add 2 grams of copper oxide to the beaker. Stir the mixture continuously. You will find that the black copper oxide disappears and a blue-green solution is formed in its place. This blue-green solution is copper chloride.
Dear students, as you have observed in the previous video about the chemical behavior of acids, in which in the last property they have reacted the acids with metal oxides. Metal oxides are basic in nature, so it results in the formation of salt and water. So now to observe the chemical behavior of bases, watch another video.
Observe the chemical behavior of these bases.
Chemical behavior?
Bases react with some metals, like zinc, and liberate hydrogen. For example, when sodium hydroxide reacts with a metal like zinc, it liberates hydrogen gas along with the formation of sodium zincate.
I don't see any gas. How can you say it's hydrogen gas?
The liberated gas can be tested with a burning splinter, which is put off with a pop sound indicating the presence of hydrogen gas.
What's next?
Bases react with non-metallic oxides to form salt and water. This is very similar to a neutralization reaction between an acid and a base. From this, it can be concluded that non-metallic oxides are acidic in nature. Consider an example. When carbon dioxide gas is allowed to pass through calcium hydroxide, it results in the formation of calcium carbonate and water.
Dear students, as you have observed in the chemical behavior of bases, that bases react with the non-metallic oxides. So maybe a question arises in your mind, what are non-metallic oxides? So non-metallic oxides are the binary compound of oxygen with non-metal, and they are acidic in nature. When they are treated with the base, they also result in the formation of salt and water, which shows that the bases, the non-metallic oxides, they are acidic in nature. Now, next we will discuss about the classification of acids and bases on the different bases. Like the first classification is on the basis of occurrence. Acids are divided into two types on the basis of their occurrence, like natural acids and mineral acids. So number one, the natural acids are actually those the acids which are obtained from the natural sources. So they are also called organic acids because organic means living source, which are obtained from the living source or life. So the examples of the natural acids or organic acids are methanoic acids, like it is also called formic acid, which is present in the legs of formica ant. Next is acetic acid, which is present in the vinegar. Oxalic acids, as we have discussed, is present in the tomatoes. The second type is the mineral acids. So the mineral acids are the acids which are prepared or which are obtained from the mineral source, or they are also called inorganic acids. They are man-made acids, or they are synthetic in nature. They are synthetically prepared. Um, it is also called inorganic acids, which is obtained from the non-living source, and mineral acids. The examples are given like hydrochloric acid, sulfuric acid, nitric acid, carbonic acid, and phosphoric acid. All these are the examples of mineral acids. Now next is the second classification, which is on the basis of number of protons, as given in your book after the concepts of acids and bases. So acids can be classified in terms of number of protons that can be given by per molecule of an acid. Like sometime some of the acids, they contain one hydrogen ion, or they give one hydrogen per molecule. Sometime they may contain two hydrogen, they give two hydrogen per molecule. So we discuss them one by one. Like the first one is monoprotic acid, which is also given the name monobasic acid. So why the name monobasic acid is given to it? Monoprotic is due to the donation of one proton. Mono means single and protic mean proton. It's taken from the proton. Like those acids which can donate one proton per molecule, they are called monoprotic acids. But why the term monobasic acid is used? Actually, as these acids produces one proton, and the one proton can neutralize one hydroxyl ion of a base. So that's why it is called monobasic acid. So those acids which produces one proton per molecule, they are called monoprotic or monobasic acid, as given in the example hydrobromic acid, which has only one proton and it can donate that proton in aqueous solution. Here are also given the examples of monoprotic or monobasic acids like hydrogen cyanide or hydrocyanic acid, nitric acid, hydrochloric acid, acetic acid. Now the second type is polyprotic acids, which is also called polybasic acid. The term poly means many and protic is taken from the proton. So those acids which produces more than one proton per molecule are called polyprotic acids. They may include the diprotic acids or the triprotic acids. Like here they have given the example of triprotic acids, like phosphoric acids. We have selected here. The phosphoric acid, when it is added to water, it give one proton in one stage. It also give the second proton in the second stage and the third proton in the third stage. And here if you look at the product side, here are hydronium ion also present. Actually the proton is very reactive species, so it will combine with the water and exist in the form of hydronium ion. So the three protons are donated by the phosphoric acid in the three steps. Actually phosphoric acid is a weak step, so that's why it do not give all protons in a single step. Then the question arises, why it is called a polybasic acid. Polybasic acid because as it produces three protons, so it can neutralize the three hydroxide ion of one base or of three bases. It depends upon the condition. So it's that's why it is called a polybasic acid. Now the examples of the polybasic or polyprotic acids are given, which is sulfuric acid. It is diprotic acid. Next is phosphoric acid, which is a triprotic acid, as it contains three protons, and the sulfuric acid and the below third one carbonic acid, they contain the two protons. So the sulfuric acid and the carbonic acid, they are called diprotic acids or basic acids, while the phosphoric acid is called polyprotic or triprotic acid. Now next is the classification of bases, types of bases. Bases are also divided into two types, like one is soluble base and another is insoluble base, as we have discussed in the this topic in the alkali and base. So what are soluble bases? Soluble bases form hydroxide ions in solution then when they react with acids. Like if we take the soluble bases, which are also called alkali, if they are added to an acid, like if the aqueous solution of a base which is called alkali, if it is added to an acid, it will react with that acid and it result in the formation of salt and water. Like here they have given that the soluble base, it is called alkali, and if it contain and releases hydroxide ion quantitatively, like a soluble base, if it gives continuously quantitatively, means a greater number of hydroxide ion, if it will contain and if it will donate in aqueous solution, then it is called a soluble base. So those bases which are soluble in water, they are called alkalis, and the alkali is considered as a strong base. Like we can say that alkali is a strong base. So the hydroxides of the alkali and alkaline earth metals, they all are soluble in water. Alkali are present in the group 1A, while alkaline earth metals, they are present in the group 2A. So the hydroxides of the group 1A and group 2A, they are soluble in water. Now what are insoluble bases? Insoluble bases, they can also react with acids directly by dissolving them in acids. They can react, but we do not take here the aqueous solutions because bases are those substances which are insoluble in water. We use the term base for those substances which do not react with water, which is insoluble in water, like as I have discussed in the difference between alkali and bases. So that substance, the base, which they may be oxides like such as copper oxides. Copper oxides, it is insoluble in water, and it do not give any hydroxide ion when added to water, and they do not dissolve in water. So in conclusion, we can say that all alkalis are bases, but all bases are, except hydroxides, they are not alkalis. This is also one of your exercise question in short questions. So in result, we can say simply that the soluble and the insoluble bases are actually insoluble bases are the bases, and the soluble bases are the alkalis. Now examples of the soluble bases and insoluble bases are provided to you on the next page. Like insoluble bases, maybe if we take the oxides, like I have discussed in the definition, copper 2 oxide, CuO, magnesium oxide, lead oxide, and the soluble bases are sodium hydroxides, potassium hydroxides, and the aqueous ammonia, it's also a soluble base. Now the classification of bases on the basis of hydroxide ion, like as I have discussed in the classification of acids on the basis of hydrogen ion. So here I will discuss the classification of bases on the basis of hydroxide ion, which it can donate. Like some bases can donate in aqueous solution only one hydroxide ion. Actually here again I will clear you that I am discussing about the alkali, but I am using the term base as you already know. Those bases, those alkalis, those bases which are soluble in water, they are called alkali. But here I am using again and again the term base, which give the hydroxide ion in water. So you do not make confuse yourself here. So the bases are classified in term of hydroxide ion that can be given by per molecule of a base when added to water. Like the number one is the monoacetic base. We can define them as the base which produces one hydroxide ion per molecule in aqueous solution. It's called monoacetic base. Actually, like there is a difference between the base and the alkali, but sometime we can use the term base instead of alkali. Like here, we are using it that those bases which give one hydroxide ion per molecule, they are in aqueous solution, they are called monoacetic base. Why called monoacetic base? Monoacetic base due to this reason, because they give one hydroxide ion. So the one hydroxide ion, it can neutralize one hydrogen ion of an acid. So mono means single and acidic is taken from the term acid. Monoacetic base mean which can neutralize one hydrogen ion of an acid. The examples are provided to you, that is sodium hydroxide, potassium hydroxide, ammonium hydroxide. They all are monoacetic bases, and they are also called like monoacetic bases because they produces only one hydroxide ion in aqueous solution. So due to the liberation of or one hydroxide ion, they are also called monoacetic base. Now, the type number 2 is polyacetic base. So, the base which produces more than one hydroxide and per molecule in aqueous solution, they are called polyacetic base. Like here are the examples given. Some are diacetic base and some are triacetic base. As the above two, barium hydroxide and calcium hydroxide, they are diacetic bases. While the iron hydroxide, which is ferric hydroxide and aluminum hydroxide, they are triacetic base, also called, all are collectively called polyacetic base. Now we will discuss about the we classify the acids on the basis of their strength. They may be strong or they may be weak. So these all topics are given in your book. So what are the strong acids? Strong acid is the acid that ionizes completely in aqueous solution and give higher concentration of hydrogen ion. Like if we add an acid into water and it dissociate completely and it give greater number of hydrogen ion, that is called a strong acid. A strong acid is also a strong electrolyte because as it give a large number of ions, hydrogen ions and negatively charged ions, so they will conduct electric current to greater extent. So that's why we can say to strong acid a strong electrolyte. Like here an example is given, hydrochloric acid, it's a strong acid because when hydrochloric acid is added to water, all the molecules of hydrochloric acids are dissociated completely into hydrogen ion and chloride ion. One thing in addition, listen it that the reaction for the strong acid we can write by such a way that a single-headed arrow is given which show the complete ionization of the strong acids. And the term AQ is given for aqueous because we are adding it to water and then it give ions, as we have discussed in the definition of the acids also. Now next is the weak acids. What are weak acids? Weak acids are the acids which do not completely ionize in aqueous solution and they give lower concentration of hydrogen ions. They are called weak acids. Like an example of weak acid is acetic acid because when acetic acid is added to water, only few molecules of the acetic acid they are dissociated, which give acetate ion CH3COO negative charge plus hydrogen ion. And but they there for their representation in the reaction double-headed half arrow is given, which shows that in the reaction mixture the undissociated acetic acid as well as the dissociated acetate ion and hydrogen ion both are present. Like as you know from your previous equilibrium sign that both the reactants and the products are present in the reaction mixture. So only few molecules will dissociate and mostly the undissociated form will be present here in case of weak acids. So the weak acids do not give ionize completely and they do not conduct electricity, or sometimes they conduct up to some extent as compared to the strong acids. So here are some examples of the strong acids and weak acids are given, like from left to right: hydrochloric acid, nitric acid, sulfuric acid, hydrobromic acid, hydroiodic acids, perchloric acid and chloric acids. In the same way, examples of weak acids are given: oxalic acid, sulfurous acid H2SO3, phosphoric acids, nitrous acid, benzoic acid, acetic acid and formic acid. All are given with their formulas. Now there is comparison. A comparison is given between the strong acid versus weak acid. In this case, like the strong acids are the molecules that completely dissociate into their ions when it is in water. Sometime maybe a question may appear in your paper. Give a comparison or difference between the strong acid and the weak acid. So the weak acids are the molecules that partially dissociate into ions in aqueous solution. The pH of the strong acid it will be very low, while the pH of the weak acid solution it will be about 3 to 5. Actually pH is the negative log of hydrogen ion, so it means the pH it has inverse relation with the hydrogen ion. Means if there will be greater number of hydrogen ion, less will be the value of the pH. As the strong acid they gives more hydrogen ion, so less will be their pH value. As the weak acid give less number of hydrogen ion, so more will be the pH value. So the pH value of the acids it will be more than the pH value of the strong acids. This we will discuss inshallah in the pH topic. Now the next point is acid dissociation constant is has a higher value, while the acid dissociation constant of a weak acid it has lower value. Acid dissociation constant is actually represented by the Ka So as acid dissociate more, greater will be the value of Ka. As the acid dissociate less, less will be the value of Ka. Like Ka, which is the acid dissociation constant, it has direct relation with the ionization or the concentration of hydrogen ions. This inshallah we will discuss in our senior classes courses. Now the next point is like strong acids, they release all hydrogen ions to the solution, while the weak acid, they do not release all hydrogen ions to the solution, as shown by the double-headed arrow in the previous examples. The next we will discuss about the strength of bases. Now, dear students, we will discuss about the strength of bases. Bases are also classified into two types on the basis of their strength, like strong base and weak base. So the first strong base are the bases which are completely dissociate in aqueous solution and they give higher concentration of hydroxide ion. They are called strong bases. As given in the examples, sodium hydroxide, potassium hydroxide, lithium hydroxides. Now their ionization is also given, like sodium hydroxide, it dissolves when it is added to water, it gives sodium ion and hydroxide ion, but it completely ionized, so they are shown by the single headed arrow which show the complete ionization. You can show the ionization of other two bases also in your notes. Now weak base. The weak bases are the bases which do not completely dissociate in aqueous solution and they give lower concentration of hydroxide ion. They are called weak bases. Like examples are given ammonium hydroxide, calcium hydroxide, and aluminium hydroxide. Now the ionization of these bases are shown as ammonium hydroxide is a weak base, example of weak base. So a double half-headed arrow is given and it ionizes and give ammonium ions and hydroxide ion. It give only a small amount of hydroxide ion and mostly the undissociated form of the hydroxide ion is present in the aqueous solution. So you can mention the ionization of other weak bases too. Here again the comparison between the strong bases and weak bases is given. Like a strong base is a compound that can completely dissociate into cations and hydroxide ion in aqueous solution, and a weak base is a compound that partially dissociate into hydroxide ion and cations, creating an equilibrium condition. Now, in the second point, a strong base it dissociates into ions almost 100%, while the weak base it partially dissociates into ions. The next point is related to pH. Like a strong base, it is indicated by the pH value closer to 14, as pH is the negative log of hydrogen ion. So, greater the number of hydrogen ion, less will be the pH. The pH and the hydrogen ion has inverse relation, but the pH and hydroxide ion, it has direct relation. This, inshallah, I will discuss in detail in the next lectures. So, as shown in the previous charts, that the bases, if they will be strong, so they will have the pH value closer to the 14. But if they will be weak, their pH will be greater than 7 but less than 14. The strong bases, they are highly reactive because they completely ionize, they give ions, so the ions can easily react then. While the weak bases, they are less reactive. In the same way as I have discussed in the acids topic, comparison between strong and weak acids, that the pKa value, the Ka value I have discussed, I think. But here the pKb value is given. So pKb means it is negative log of Kb. Like Kb has direct relation with the strength of base. But pKb is actually the negative log of Kb. So pKb mean pKb has inverse relation with the strength of bases. Like pKa term we can use for acids, so the pKb term we can use for the bases. In the same way, directly we can use Ka, Kb, or pKb, pKa, they are used indirectly. We take the negative log due to this reason, because sometimes the values of the K and Kb, they are very small. So when we take the negative log, the values convert into positive values if they are given in the negative value. So in case of strong bases, the pKb value it is almost 0, but in case of weak bases, the pKb value it is very high. So actually I have provided this extra knowledge in this lecture to make your concept clear. Otherwise, you do not confuse yourself in this pKb and pKa. This inshallah we will discuss in your senior class courses or maybe in the next chapters. Now, dear students, in order to make your concept clear about the strength of acids and bases, strong acid, strong base, weak base, uh, observe this video.
Strong and weak acids and bases. So what does it mean to say that an acid or a base is strong? Let's consider a prototypical strong acid, hydrochloric acid. If we put hydrochloric acid in water, it dissociates into a proton and a chloride ion. Because it dissociates completely, we say it's a strong acid. What about sodium hydroxide? If we put sodium hydroxide in water, it also dissociates completely. So we call sodium hydroxide a strong base. If we put ammonia in water, it dissociates only a little bit. Therefore, we say that ammonia is a weak base. There are only a few strong acids and strong bases. For IB chemistry, you specifically need to remember hydrochloric, nitric, and sulfuric acids. You should also be familiar with hydroiodic, hydrobromic, perchloric, and chloric acids, as most chemists also consider those to be strong acids. As for strong bases, all the group 1 and group 2 hydroxides are considered to be strong, though IB chemistry syllabus only specifically mentions the group 1 hydroxides and barium hydroxide. If it isn't on the short list of strong acids or strong bases that you just learned, then you should consider an acid or base to be weak. That said, we still need to know a few examples for the IB. Acetic or ethanoic acid is considered to be a weak acid, as are almost all other organic acids. Carbonic and phosphoric acid are other examples of weak acids. We've already learned that ammonia is a weak base, and so is ethylamine, which is an organic base that has an amine group. In fact, all bases that include an amine group are considered to be weak bases. There are 3 ways to distinguish strong and weak acids and bases: electrical conductivity, reaction rate, and pH. We've already learned in topic 4 that anything that dissociates into ions in water will conduct electricity. Well, acids and bases by definition do dissociate in water. If they conduct electricity very well, then that's a sign that it's a strong acid or base. If they conduct electricity only mildly, then it's a weak acid or base. Strong acids and strong bases not only dissociate more, i.e. push their equilibrium far to the right, they also react faster than a weak acid or a weak base. Finally, the pH scale can of course tell us if something is a strong or weak acid. If we put a strong acid in water, we'll measure a low pH value closer to the 0 side. If we put a strong base in water, we'll measure a high pH value closer to 14. Weak acids and weak bases will measure out closer to the middle. That's it. Thank you for watching.
Now we will discuss about the uses of acids and bases. This is also for making your concept clear. Actually, it's not given in your course, but you must be familiar about their uses. Like hydrochloric acid is used in industry to remove rust from the metals before they are painted, like as you know from your 9th class course. Sulfuric acid is used to make fertilizers and detergents. Ethanoic acid is used in the vinegar for cooking and to preserve food such as vegetables. And citric acid is used in making fruit salts. Now, dear students, to observe the uses of acids, watch this video.
Acids have various uses. Sulfuric acid is used in the manufacture of fertilizers, paints, dyes, chemicals, plastics, and synthetic fibers. It is also used in car batteries. Nitric acid is used in the manufacture of fertilizers, explosives like TNT, dyes, and drugs. Hydrochloric acid is used before galvanizing to remove oxide film from steel and also as a descaling agent for boilers. It is also used in the textile, leather, and food industry. What's the matter, Sam? You look pale. Is something wrong?
I have overeaten, and now I am feeling some uneasiness in my stomach. What should I do?
This problem is known as acidity, which is due to excessive intake of spicy food. This acidity of food is relieved by using an antacid which is a mild base like sodium bicarbonate. A mild base neutralizes the excess acid produced in the stomach and makes you feel relieved.
Now next is the uses of bases. Sodium hydroxide and potassium hydroxide, they are used in making soaps. Ammonia solution is used in window cleaners. Magnesium hydroxide is used in the toothpastes to neutralize the acid produced by the bacteria. And calcium hydroxide, which is also called slag lime, it is used to neutralize acids found in the acidic soil. Now dear students, in order to observe the practical uses of the bases, kindly watch this video.
Bases neutralize the acidity caused in my stomach.
Not all bases, only mild bases neutralize the acidity. Apart from that, bases have a variety of uses in daily life. Let's look at some of them. Bases like sodium hydroxide are used in the manufacture of soaps, paper, and synthetic fibers like rayon. A base like calcium hydroxide is used to manufacture bleaching powder. Bleaching powder is used as a disinfectant. Magnesium hydroxide is used as an antacid to neutralize the acid produced in the stomach. This is similar to the one you have taken to obtain relief from your acidity problem. Bases are useful to plants too. A base like ammonium hydroxide is used in the preparation of fertilizers like ammonium phosphate and ammonium sulfate.
Now, what are indicators? As we have discussed in our topic, indicators are the substances which show different colors in acidic and alkaline solution. Like as we have discussed already, the blue and red litmus paper. So litmus is a common indicator. It is red in the acidic solution and blue in the alkaline solution. Like as we have discussed in acids, the blue litmus paper turns red, while in case of bases, the red litmus paper turns blue. We can identify them by changing the color of the litmus paper. So litmus paper is actually an indicator, one of the indicator. Other important indicators are shown in the table on the next side. Like here is given methyl orange. Its color is given in the acid as well as in the base. Its pH range is also given, at which the color change of indicators also takes place, like methyl orange and phenolphthalein. These are also indicators which we use in laboratory. We use inshallah in the practical in chemistry lab. So methyl orange is red in the acid, but the pH, which is 4, at this pH it will change its color. When we add a strong alkali into that acid, it turns yellow. In the same way, the litmus paper, which is red in the acid, it turns blue in the alkali, and the color change pH range is 7. In the same way, phenolphthalein, which is colorless in the acid, but it turns pink when we add an alkali into the acidic solution, and its color change takes place at pH 9. Now to observe the about the indicators, watch this video.
Is the one which exhibits different color in acids and bases. Red cabbage is a visual indicator used to detect acids. The cabbage leaves are purplish in color but turn red in the presence of an acid. Onions are called olfactory indicators because of their characteristic smell. This smell is destroyed by the action of a base. The most common indicator that you may have come across in the laboratory is litmus, which can be in the form of a solution or paper. Litmus is a natural indicator and is extracted from lichens. It is dyed blue and red to detect changes in color. Take 1 milliliter of any acid and put it into a watch glass and then place a red litmus paper in it. There is no change. In the same setup, place a blue litmus paper and see what happens. The litmus paper will turn red, indicating the presence of acid. This shows that acids turn blue litmus red. Apart from natural indicators, there are a few synthetic indicators such as methyl orange and phenolphthalein. The neutral color of methyl orange is orange, and it turns red in an acid and yellow in a base. Phenolphthalein is colorless. It does not change in an acid but turns pink in a base.
Dear students, as you have observed in the previous video, that the indicators may be naturally occurring or they may be synthetically artificially prepared. Like now the summary, observe the summary video which is given in the end of this lecture.
Acids and bases are everywhere. They're used to make foods, soaps and detergents, fertilizers, explosives, dyes, plastics, pesticides, even paper. Our stomachs are very acidic. Our blood is slightly basic. Our proteins are made up of amino acids, and the letters in our genetic code, those A's, T's, C's, and G's, are all bases. You were probably taught how acids and bases behave on the molecular level. You were probably never taught that a long time ago, like ancient Greek ago, before anyone knew about atoms or molecules, acids and bases were defined by how they behaved. Acids tasted sour and corroded metals. Bases felt slippery and could somehow counteract acids. When molecules dissolved in water interact, they're exchanging two main currencies with their surroundings: protons, also known as hydrogen ions, and electrons. Depending on how a molecule is composed or shaped, it may be willing to donate or accept either protons or electrons with some other community member. And some molecules are far more aggressive than others when it comes to donating or accepting either currency. Remember that protons are positively charged and electrons are negatively charged. So if a molecule is willing to give up a proton, that's not too different from it being willing to accept an electron. Either way, it's becoming more negatively charged. Other molecules are willing to accept a proton or give up an electron. These are becoming more positively charged. Some substances are so aggressive about donating their protons that when they get a chance, all of the molecules in a sample will dump a proton, sometimes more than one, to the surrounding water molecules. We call these strong acids. Meanwhile, some compounds are so ready to accept a proton that they won't wait around. They'll just rip one off water, which usually has two protons but is generous enough to hang out with just one. We call these strong bases. Other acids and bases are not so strong. They may donate just a few of their protons to water, or accept just a few protons from water, but most of their molecules stay exactly the same. If left alone in water, they'll reach some equilibrium point, where maybe only 1 out of 100 or 1 out of 10,000 of their molecules has exchanged currency with water. As you might guess, we label these acids and bases weak. But in the common sense of the word, they're not weak. The vinegar in your salad dressing that you can smell from across the room, that is a weak acid. The ammonia you spray on glass for a streak-free shine, that is a weak base. So it doesn't take much to be an active player in the chemical economy. Most acid-base chemistry takes place in water, which can act as either an acid or a base, accepting deposits and enabling withdrawals like a 24-hour molecular ATM. And when a proton deposit customer, that's an acid, and a proton withdrawal customer, the base, shop at the same time, their net effects on water's account may cancel out, and we call this neutralization. Now, certain molecules can behave as acids or bases without water, but that's another story. Let's end by saluting water as the resilient and fair banker for acids and bases. It's always open for business, doesn't charge interest, and will never foreclose on your molecules. Which is more than I can say for
So, dear students, although today lecture was very long due to a number of videos, but these all videos are very important and helpful to you, inshallah, in making your concept clear. Now the homework, short questions and the long questions both are taken from the exercise. So you try to solve them and write your notes. Take help from this lecture too. Now thank you and Allah Hafiz.